Good morning, students. So today we are going to discuss about theoretical distributions, frequently asked questions. So let us see Bernoulli distribution. See some list of questions which are frequently asked in the previous years. I have written on the board. So one by one I will be explaining it. So kindly follow all those questions. Clear? So let us see. Define a Bernoulli variate. So as you all know that Bernoulli distribution, it was first proposed by James Bernoulli, right? It was first proposed by James Bernoulli. Now define a Bernoulli variate is, let x be a discrete random variable and its PMF p of x equals to p power x q power of 1 minus x, where x takes the values 0 and 1. Then the variate x is called as a Bernoulli variate and its distribution of x is called as a Bernoulli distribution. Are you clear, guys? So Bernoulli variate is a definition of Bernoulli variate is, let x be a discrete random variable with its PMF p of x equals to p power x q power of 1 minus x, where x equals to 0 to 1, and then the variate x is called as a Bernoulli variate and its distribution of x is called as a Bernoulli distribution. Clear? Next, coming to next one. If x1, x2 and so on xn are independently identically distributed, in a shortcut we have written IID, independently identically distributed Bernoulli variates with parameter p, what is the distribution of x1 plus x2 and so on xn? As you all know that Bernoulli distribution lies from 0 to 1. If you take up to n number of trials, then that becomes binomial trials. Clear? Now x1 plus x2 and so on xn, what kind of distribution it is? It is a binomial distribution. Clear? That is question number 2. It's a binomial distribution. Next, third one. PMF of Bernoulli, range of Bernoulli, mean and variance of Bernoulli distribution with parameter p. Right? So first of all, what is PMF? So p of x equals to p power of x q power of 1 minus x, where x takes the values 0, 1. So this is the PMF of Bernoulli distribution. And then range. So range is 0, 1 is a range because where x takes the value 0 to 1. Then mean. Mean of Bernoulli distribution is nothing but parameter p. So p is a constant, parameter, statistical constant it is. And then variance, pq, standard deviation becomes root pq. And the relationship between mean and variance in a Bernoulli distribution is, mean is always greater than variance. Clear? So mean will be always greater than the variance. Next, give an example for Bernoulli variate. What is the example of Bernoulli variate? A baby is born. Possibility of getting a male or a female, baby boy or baby girl. Clear? And out of so and so when birth is occurring. That is one thing. When a coin is tossed, possibility of getting head or possibility of getting tail having an equal chance. Right? So under a single trial, the Bernoulli occurs. Clear? The outcome depends on a single trial, either success or the failure. Success is denoted as P and failure is denoted as Q. And success is denoted as 1 and the failure is denoted as 0. Right? So these are the questions from Bernoulli distribution. Next one, binomial distribution. The PMF, range, mean, variance and standard deviation and relationship between mean and variance of a binomial distribution. First, let us know the definition of binomial distribution. Let x be a discrete random variable and its PMF p of x equals to ncx p power x q power of n minus x, where x takes the value 0, 1, 2 and so on n, and p always lies between 0 to 1. Now the PMF of a binomial distribution is p of x equals to ncx p power x q power of n minus x, where x take the values 0 to n, And what is the range? 0 to n is the range of binomial distribution. Now what is the mean of binomial distribution? Mean equals to NP, variance NPQ, standard deviation root of NPQ. So the mean, variance and standard deviation. Now what is the relationship between mean and variance? As you all know that Q value always lies within 1. Then parameters you apply on both the sides. Therefore NPQ becomes less than NP. So you know that NPQ is a variance and NP is a mean. Therefore variance less than mean or mean greater than variance. That is the relationship between mean and variance of a binomial distribution. Now, what are the features of binomial distribution? Features are nothing but the properties. As you know that there are some list of properties. First one, writing the PMF is one of the property of binomial distribution. P power x, NCx, P power x, Q power of n minus x, where x take the value 0 to n. And writing range is another property. And mean, variance, standard deviation, all three writing is property number 3. And then the relationship between mean and variance writing is another property, property number 4. And property number 5. Look at this question. What value of P is binomial distribution symmetrical? Exactly, we can take it as half. If P equals to half, we can say the binomial distribution is symmetrical, right? And then there are some more properties. Finding the mode value. How? If NP is an integer. If NP is an integer, then the mean equals to mode. Remember, whenever you calculate the mode of binomial distribution, if NP is an integer, then the mean and mode are equal. Then, if it is not an integer, then how to calculate the mode value? Whatever the highest probability after distributing the x, the highest probability, and its x becomes the mode. Clear? Highest probability and its x value becomes the mode when NP is not an integer. If it is an integer, directly the mean and mode are equal. If it is not an integer, the highest probability and its x becomes the mode. Clear? Next, if P greater than half, or if P greater than half or Q less than half, then the binomial distribution is negatively skewed. Then the binomial distribution is negatively skewed. If P is more than half and Q is less than half, then it is negatively skewed. Quite opposite. If P less than half or Q greater than half, then this becomes positively skewed. So then that becomes positively skewed. And then limiting form of binomial distribution to Poisson distribution. What are the limiting form? If n is large, P is small. So n is large means n tends to infinity, P is small means P tends to 0. Then NP becomes lambda. Lambda is the parameter of Poisson distribution. Under these two conditions, the binomial can be converted to Poisson distribution. Now, binomial distribution tends to normal distribution. What it is? Binomial tends to normal distribution. If n is large, P and Q are almost equal, but they are not equal. They are almost equal. Then we can say that binomial distribution tends to normal distribution. Clear? So these are all about properties of binomial distribution. So these are the most frequently asked questions from binomial distribution concept. So the next distribution is Poisson distribution. The PMF, range, mean, variance, standard deviation, and the relationship between mean and variance in Poisson distribution. That is the first question. Most frequently asked questions. Among these, definitely one or two they may come, right? So I mean, in the previous years they have asked for 1 mark or 2 mark. First, PMF, probability mass function. P of x equals to e power minus lambda, lambda power x by x factorial, where x takes the value 0, 1, 2 and so on up to infinity. Lambda must be greater than 0. So this is the probability mass function of Poisson distribution. And here, especially if you observe lambda is the parameter of a Poisson distribution. It's a statistical constant, right? So this lambda is a parameter of Poisson distribution. Next, what is the range of Poisson distribution? Range is nothing but 0 to infinity. This is the range of Poisson distribution, right? Only the difference from binomial to Poisson distribution is, in binomial distribution, small n is fixed, right? Number of trials are being fixed. But where in Poisson distribution, the number of trials are not fixed. Clear? So up to infinity it goes. But end of the day, the n trial will be identified. But wherein n is not fixed well in advance in Poisson distribution. That is the reason up to 0 to infinity we have considered. Mean of Poisson distribution. See, mean, variance are nothing but lambda. So the mean and variance of a Poisson distribution are always sync. So here you got the relationship between mean and variance of Poisson distribution. In this distribution, the mean and variance are equal. You have to write the answer Poisson distribution. Standard deviation is nothing but square root of variance, nothing but root of lambda. Next, features of Poisson distribution. First feature is writing the PMF. Second feature is writing the range 0 to infinity. Third one is writing mean variance, they are equal and the relation is also equal between mean and variance, and standard deviation is root lambda. Now, the remaining properties. If lambda is an integer, then how to calculate mode? It has a bimodal, lambda minus 1. We have two modes. If lambda is an integer, mode value becomes lambda and lambda minus 1. If lambda is not an integer, then it will be a unimodal. If not an integer, the integral part becomes the mode. Are you clear? Suppose if lambda is 3.5, the integral part is 3, therefore the mode value becomes 3. If lambda is an integer 3, then this becomes bimodal, 3 and 3 minus 1, that is 3, 2. Bimodes, you will be getting it. Clear? Two mode values. If lambda is an integer, then it has a bimodal. If lambda is not an integer, and it is a unimodal. Right? Next, limiting form of Poisson distribution to normal distribution. Same thing, only one, lambda tends to infinity. If lambda is large, then the Poisson distribution tends to normal distribution. Clear? Coming to the examples of Poisson distribution. Number of telephone calls per minute in a day. See, well in advance it can't be fixed how many telephone calls will be receiving it. But end of the day, we can easily identify how many telephone calls are being received. Next, number of accidents occurring in a day. Right? So that is also well in advance can't be fixed. Like binomial, n how it is fixed. But where in Poisson distribution, n is not fixed. Up to infinity it goes. But they are discrete values. Distinct values can be identified and discrete variables only can be identified. I mean 0 to n can be observed, but it is not fixed in Poisson distribution. That is the only difference. So these are the examples of Poisson distribution. So these are the most frequently asked questions from distribution number 3, Poisson. Clear guys? So in the coming video, I am going to discuss about hypergeometric distribution as well as normal distribution. I mean continuous cases. I am going to discuss. Right? With this, I am going to wind up this video. Okay students, as I said that in the next video I am going to discuss about hypergeometric, but I would like to continue in the same video because all the discrete variables in one video I would like to give. So let us continue the hypergeometric distribution in the same video itself. Next, hypergeometric distribution. Even this hypergeometric distribution is a discrete distribution, right? Wherein the distinct values are being identified. Now, first question. Probability mass function, range, mean, variance, standard deviation, right? And also even you can write parameters. First, probability mass function. P of x equals to ACx BC n minus x by A plus BC n. So this is the probability mass function of hypergeometric distribution. where x takes the value 0, 1, 2 and so on, minimum of a comma n. And here a, b and n are the parameters of hypergeometric distribution. Clear? So this is the PMF of hypergeometric, and range of hypergeometric is 0 to minimum of a comma n. Next, what is the mean? Mean of hypergeometric, NA by a plus b. This is the mean of hypergeometric, NA by a plus b. And variance, NAB of a plus b minus n whole divided by a plus b whole square of a plus b minus 1. So this is the variance of hypergeometric distribution. Next, what is the standard deviation? Standard deviation is nothing but square root of variance, right? Now, what are the parameters? A, B and n are the parameters of hypergeometric distribution. Next, features of hypergeometric distribution. Features, nothing but a properties. Writing the PMF is one of the property. Writing the range 0 to a comma minimum of a comma n. Writing another property. Mean variance SD. Writing property number 3. And then parameters, writing property number 4. Next, limiting form of hypergeometric to binomial distribution. Listen carefully. If a plus b is large, then p equals to a by a plus b, right? 1 second. Anyhow, n will be known in hypergeometric distribution. If a plus b is large, then p equals to a by a plus b. Then n and p, both you will be getting it. Are you clear, guys? So if a plus b is large, then n is already known in hypergeometry, then p becomes a by a plus b. Then n value and p value. N and p are the parameters of binomial distribution. You know that, right? So that is the limiting form of hypergeometric to binomial distribution. Next, examples of hypergeometric distribution. What are the examples? Number of boys in a committee when 5 students are picked from 30 boys and 20 girls. Right? That is one example. And the second example of hypergeometric is number of vegetarians of 8 selected from a hostel in which there are 12 vegetarians and 8 non-vegetarians. So these are all the examples of hypergeometric distribution. Next, coming to conditions. What are the conditions to be applied in hypergeometric distributions? I can say that conditions characterize the hypergeometric distribution. Condition number 1. The results of each draw can be classified either one of the 2 categories. See, each draw will be observed one of the 2 categories. For example, in any example, if you take boys and girls, right, 2 characteristics are given, qualitative characteristics. In that, any one of the characteristics will be chosen, right? Based on that, we will be calculating the probability of hypergeometric of so and so x, isn't it? So that way, the result of each draw can be classified into one of the 2 categories. That itself is the first condition to characterize the hypergeometric distribution. Second one is the probability of success changes on each and every draw, because you are following without replacement case. So without replacement, whenever you are selecting randomly any kind of things from any random experiment, right, each and every draw you are doing without replacement policy, without replacement case. Without replacement means probability keeps on changing on each and every draw, whatever you select. So these are the next 2 conditions. Next, the last one, the draw is repeated for a fixed number of times from a finite population. The draw is fixed for n number of times for a finite population. Clear? From a finite population. These are the 4 conditions which are to be characterized the hypergeometric distribution. So these are the most frequently asked questions in the previous years from hypergeometric distribution. I hope I am clear about Bernoulli, binomial, Poisson and hypergeometric. So all these 4 distributions are discrete distributions wherein the distinct values of x will be identified in all these distributions. Are you clear, guys? Next, in the coming video, I would like to discuss about the normal distribution, chi-square and t-test. All these three distributions comes under continuous distributions. I mean continuous random variable, continuous cases, right? So all these discrete cases, kindly observe all the questions. So definitely you will be knowing how the question will be asked and what answer must be written for that question, right? Especially 1 mark and 2 mark, because 5 mark, 10 mark easily you could able to write, but wherein 1 mark and 2 mark keenly you have to observe and write it, because 2 choice, even though they are there, but still we cannot take any risk in 1 mark and 2 mark, because those 1 mark 2 marks only easily we commit error, right? So to avoid those, we are preparing all these frequently asked questions in the previous years from each and every distribution, as well as from each and every chapter. So I hope I am clear, guys. So please do follow all the videos, right, without fail, and then continuously thoroughly observe all the videos and practice. You have to do it. Just by observing it won't be, just practice it. Whenever I am just saying it, you practice that and you read and you learn properly, then only you can achieve higher. Clear? So with this, I am just going to wind up this session. In the next video, we are going to start with normal distribution as well as the other continuous distributions, chi-square and t distribution. Guys, so I think everybody is doing great. Stay home, stay safe. Thank you.